In this video, we're going to be taking a look at a rotational dynamics question where a block is connected to a string and the string is attached to a pulley that has a significant effect on it because of its rotational inertia. So this type of problem is a little bit difficult because it requires some linear ideas and some rotational ideas. So let's go ahead and take a look at this problem. We have a pulley that has a radius of 1 meter. It has a mass of 3 kilograms, and we have a block that has a mass of 5 kilograms. And we want to find out the linear acceleration of how fast this block falls. So we know that if something is in free fall, it's going to have an acceleration of negative 9.8 meters per second squared. So obviously, being attached to a rope to a pulley, it's going to have something that is between 0 and negative 9.8 meters per second squared. All right, now for analyzing this block over here, we have the force of tension up and the force of gravity straight down. So just analyzing this 5 kilogram block, we can say that the block is trying to move down, so it has an Fg pulling it minus Ft, and that equals m times a. So we can go ahead and say 1/2 mRa equals FTR, and then also one of the R's is going to drop out. Now, the connection between the two, meaning the 5 kilogram block and the 3 kilogram disc or pulley, is this Ft. So they both experience the same Ft. This Ft is basically a restrictive force on the 5 kilogram block, and this Ft is providing the torque on this disc over here. So I see an Ft over here, and I see an Ft over here. So what I'm going to do is go ahead and do a substitution. So I have Ft equals 1/2 ma, and I know that Fg equals mg. So this is the mass of the 5 kilogram block times g minus, and then I'm going to go ahead and sub this in, 1/2 ma equals ma. Now I want to solve for the linear acceleration. So what I'm going to do is go ahead and add this over to that side. So before I continue, there's one distinction I forgot to make. This is the mass of the 5 kilogram block that we're talking about. And then this 1/2 ma came from over here when we were talking about the disc. So this mass is the mass of the 3 kilogram disc. So what we can do is we can try to combine some terms, and we have mg equals, and then I'm going to add the 1/2 m3a to the other side, but I'm going to pull out the a because I know I'm going to want that a little later. So it's going to be 1/2 the mass of the 3 kilogram disc plus the mass of the 5 kilogram block. All right, so what I can do is go ahead and divide both sides by this value over here, which is basically the same thing as cross multiplying it under here. And that's going to leave me with the mass of the 5 kilogram block times g divided by 1/2 mass of the 3 kilogram disc plus the mass of the 5 kilogram block. Now we can go ahead and plug in our values. So we have 5 times 9.8 divided by 1/2 times a 3 kilogram disc plus the mass of the 5 kilogram block, which is going to give us 49 divided by 6.5, which equals 7.54 meters per second squared. which is the linear acceleration of the 5 kilogram block, considering it's attached to a string that is rotating a pulley that has rotational inertia. And we can go ahead and put a negative here if you like, because it's directed downwards, because this mg is directed in the downward direction, which matches up to our original idea that our acceleration should be less than the free fall acceleration of negative 9.8, just slightly less because of the rotational inertia of that pulley. So to sum things up, that Ft is really our connection between our rotational dynamics and our linear values over here. So you want to make sure that you do use quite a few different equations and substitutions to get closer to your linear acceleration, as we did on this side with the orange and blue. And then we found that connection with the Ft over here, and then substituted in for this Ft over here because it's the same force of tension. And then from there, just doing a little bit of algebra and rearranging, and then we found that final linear acceleration of negative 7.54 meters per second squared. So I hope that was helpful for you. Thanks for watching and listening.